Alright, so hello and welcome back to the continued coverage of the AS and A-level Python series. And in this episode, we're going to be looking at a very important concept, especially in inheritance. That is the concept of using the super function, as it were, in Python. Or rather, the super keyword in Java. In languages like Java, it's called the super keyword. But in Python, it's actually not a keyword, but it's a function. But essentially, we'll just refer to it as let's just say super function or super keyword. I might just be using those terms interchangeably throughout the video, but it's actually a function in Python. So the super function is used to call methods from a parent inside a child. And like I said before, this is very important in inheritance because it's going to avoid directly referencing the parent class, as it were. So for this to actually make sense, let's actually go ahead and make use of an example. So maybe let's start by declaring a class called shape. So this is going to be the parent class, as it were. Then let's have the constructor here. So in itself, then we want to have at least one parameter going on in there, which is name. That is the name of the shape. Then here we can just go and say self.name is equal to the name that's going to be provided when we instantiate that particular shape object. Then we want to have a function that's called describe, and it's actually just going to tell us the name of the shape, as it were. So maybe what we can simply do is we can just print fprint the name of the shape, as it were. So this is so we can then take the name of the shape. So it's going to be self dot name, right? Then we are going to print the name of the shape, as it were. So this is the super class, right? So let's go ahead and have a subclass, the first subclass for this particular example. So we are going to instantiate create a class called rectangle. Then it's going to inherit from the shape class, as it were, is it? So this is actually going to be our first example, looking at how we can make use of super, so that we can access this constructor as well as this particular function that is inside of the shape function, as it were. So inside of the rectangle class, it's going to have its own constructor, of course. So let's have its own constructor going on inside of here. Then what we also want to do for this one, we don't want it to have the name, because remember it's inheriting from the shape class as it is on line 11 there. So it means that we just need to implement maybe the width and the height. Maybe we can use these attributes to calculate the area of this particular shape, as it were. So here, instead of saying it's actually my IDE doing the work for me right here. So let me just clear that out so that I can explain as I write. So this is the constructor for the rectangle shape. Notice that it's inheriting right on line 11 there, and it's also going to be implementing its own functionality right there on line 12. So aside from the name of the shape, it's going to also have a width and a height, as it were. Then on line 13, what we need to do now is we need to call this particular constructor, as it were. So we can say super, remember it's a function, it's not a keyword like I said earlier on. So super dot, we want to call the constructor from the super class. So init, right? So you will remember that the constructor from the super class is actually, or from the parent class, it takes a parameter of, it has a parameter called name. So we have to specify the name for our particular shape, this one. So this one is a rectangle. So here what we are doing on line 13 is we are calling the super class constructor, as it were. So that's what we are doing right here. Then of course we can then go ahead and have the values or the attributes set for this particular class. So we have self.width is going to be the width that the user provides when they instantiate this object. And let me just go ahead and copy this and paste it here. Then of course we also have the height going on for this particular shape. So shape.height, self-height is equal to height, right? Then we can go ahead and then implement another function inside of this particular class called area. So remember always, whenever you define a function inside of a class in Python, you are also always going to have to pass self as a parameter in there. So that's what we're doing there on line 17. So area, it's going to simply return self dot width multiplied by self dot height. Then we can also implement the describe function for this particular class, is it? So we can just go ahead and say def describe, then remember to pass self there as a parameter. Then instead of now having to rewrite or reinvent the wheel, as it were, we can just inherit this describe function from the super class, as it were. So the way we go about it is to make use of super, then dot, then describe right there, is it? So here we are basically extending the parent method, extending the parent describe method, is it where? That's what we're doing here on line 21 there. All right, so instead of just printing describe, what we want to do is we also want to instead of just printing the name, we also want to print the area, as it were. So we can print this, so we can say the width is this much. So we can say self.width, then put a comma, then we can say height, then we can also specify the height, is it? So we can self.height, we can format print the height, as it were. So when we call this, rather when we run this code later on after instantiating a rectangle object, you see that it's going to describe the name of the shape, and then it's also going to add the height, the width and the height, as it were, because we are basically extending the describe function that we've already defined there on line number 9, lines number 8 and 9 for the shape superclass, as it were. Yeah, I think we can go ahead and run this maybe and see this in action. So if I run it right now, we're not going to see anything. So maybe what I can do is I can create outside of the function today, outside of any class, I can instantiate a rectangle object. Right? So rectangle, and then I'm going to pass maybe 4 and 5 as arguments there. Then we can go ahead and simply maybe say r dot describe, right? Maybe just to demonstrate how it works in this particular instance. So let me just go ahead and run this. So you see that it says this is a rectangle, the width is 4 and the height is 5, is it? So if you come back to the code, you remember that we didn't have any this is implemented inside of this particular function. Is you can actually see that on line 21 there, we just use the super function to extend, or rather to call the describe method that is inside of this particular shape class, as it were. So that's how you can make use of the how you can make use of the super keyword when you are extending the function or a method inside of another class. And you can also make use of the super keyword to take or to extend, or rather to call the superclass constructor, as it were, like what we did on line 13 there. So yeah, that's how you can just add on to the functionality of your methods inside of a class, as well as call the super constructor, the superclass constructor, as it were, like what we did on line 13 there. Then maybe let's just have more examples so that we can actually see this we really drive the point home, as it were. So maybe let's have another class called circle. So I'm going to move a bit quicker this time around. So circle and try and talk less. So circle shape, it's extending the shape class, right? So you know by now, you know that we have to implement the constructor for this particular circle class. And then here we have to provide the name. So just as we did before, it's going to be a circle, this one. And then besides having the name, we don't need the name because we are just going to be making use of the superclass constructor. We just want to have a radius here for our circle. So that's what we are going to do here. Then we are going to say self.radius. Then it's going to be equal to radius. Then we can also have a function that's going to calculate the area for this particular circle object later on when we instantiate it. So we can then go ahead and return for the circle we need the value of pi. What can I do? Should we hard code it? Alright, no. Maybe what we can do is let's go ahead and import math here so that I hope I did cover imports in this series. I hope. So we're making use of the built-in math class, right, or the math library in Python. So we want to make use of the pi as it were for calculating the area of this particular circle. So we can come here and say math. So from the math class we can say math.pi. So we are making use of pi, which is found inside of the math library as it were in Python. So it's going to be self.radius then to the power of 2. So remember, to the power of 2, it's actually 2 asterisks in Python. Then let's have the describe function as before, like we did in the rectangle class. Then super.describe. Then we can also we don't want to return. It's my IDE completing the code for me. I just want to extend this functionality. So this one, it's going to say print, and then we are printing this, so we can say radius. Then we can have the radius here. So self.radius. Then what else can we do? Yeah, we're done here. Maybe let's have one more shape. Let's save square. Square is more or less the same with the rectangle. Maybe let's save triangle. It's a different shape altogether. So it's inheriting shape here. Then of course its own constructor here, but it's also going to inherit from the parent class constructor, but we don't want it to have the name attribute because it's already provided for by the parent class constructor. So we want to have the base and the height as it were. And the name here is going to be triangle. Then we can say self.base is equal to base, then self.height is equal to height. Then we can have the area function here, or a method as it were. So area self, then it's going to return. Maybe we can say it's half base times height, so you can say 0.5 multiplied by self dot base multiplied by self dot height. Then we also need to have a describe method or a describe function going on for this particular class. So we can say describe, then it has to take the self parameter, it's the row. Then we are extending the functionality of the describe inside of the superclass. Then on top of that, we are going to add our own functionality as it were. So we can format print the base, then it's going to be self dot base, comma, height. Then we can say self dot height, right? So there we go. So here you see that we have three types of shapes, right, that are inheriting from the shape class. So from the parent constructor, they are going to get the name, right? Then of course from the describe, it's just going to say what type of shape it is. Then here you see that on line 14 we are referring to the superclass constructor, and we are taking the init, which is the constructor, and we are giving it a name, which is a rectangle. So this is going to happen for all the three other for the two other shapes that we have going on, is it? Then for the describe function, we are also invoking, we are also calling this describe function. So for each class, for each of these classes, it's actually going to say what type of shape it is before going on to add its own other functionality. Like for instance, in this circle class here, you see that besides just saying that this is a circle, it's also going to say radius, is it? Then it's going to display the radius right there. And it also goes for the triangle as it is. So this is how you make use of the super function in Python, right? So remember, we said that the super function is used to call methods from a parent inside a child, is it? So the parent will be the super class, and the child will be the subclass, as it were. Right? So we make use of super so that we can call the parent constructor on line 14 there. Then we can also call parent methods inside of the child, as it were. So that's what we're doing with super here. So to now demonstrate this in action, let's go ahead and instantiate some objects. So we are going to have rect, which is going to be equal to a rectangle object, which is radius 7, rather length 7 and 10. Then we can have a sec, which is a circle. Maybe we can give it a radius of 3. Then we can have a tri or trier, which is going to be equal to a triangle, and it's going to have a base of 12 and a height of maybe 9. Then what we can go ahead and do is we can we want to print these shapes, as it were. So maybe what we can do is we can put these inside of a list. So you can say shapes is equal to rect, sec, and trier, right? Then maybe let's just say my shapes here. My shapes is equal to this. So we have the objects inside of a list there. So maybe we can use a for loop to iterate through each of the shape. So we can say for shape in my shapes, what we want to do, we want for each shape to call the describe function or the describe method. So it's going to describe what type of shape it is, and it's also going to print we're going to print area for that particular shape. So here we can just print, so we can say shape. So notice that each shape object here actually is the area function, like when we define the classes there. So area, then yeah, then we can have maybe a demarcation. If I want to put a demarcation, maybe I can just print this minus times 20. This is actually not needed. You see why I did put this, but you don't really need this. And that's one of the good things about Python. You can do such things as this. Alright, so let's go ahead and run this. Right, so you see that we have so it says this is a rectangle, width is 7, height is 10, then the area is 70. This is a circle, radius 3, area is that much, and this is a triangle, base is 12, height is that much, is it? So that's how you can, yeah, I think I demonstrated the use of the super keyword, really. I hope you did catch what I was trying to put across here. Yeah, so I think that's just about it for this video. Hope you learned something. See you guys in the next one.